Alright, 2-2, solving equations by using addition and subtraction. The addition property of equality we'll look at horizontally. So if I had like 5, I could throw an equal sign between that and say, well, 5 is equal to 5. And an equation is all about balance. So that if I wanted to, I could take that same value of 5 and add 1 to the left side. And as long as I add another 1 on the right side, I have not changed the truth of this equation. And here's what I mean there. The equality tells you that one thing is equivalent to another. And sure enough, 6 is equal to 6. So the whole deal behind this is that we can figure out equations by moving things around. And as long as you make one change to one side and do it on the right side as well, you're going to be good. Like, it'll still be a true statement. It'll look different, but the equation is still true. Now let's look at this vertically. And I really prefer to do these vertically. So I'm starting with the same exact thing as before. On the left side, I'm going to add 1. On the right side, I'm going to add 1. Now, did you see how I just did that line there? Well, the reason I did that line is because we're doing addition. And when you were young and first learned how to do addition, you added 1 and you wrote a 6. But this line was drawn to step the starting problem away from the result. So you were like, okay, well, if I had 6 and I had to add 3, my line is there to help me know that my result is here. So after we've added 1 in this step, I'm drawing a line here, just like old addition problems, so that when I look at this left portion of my equation, 5 plus 1 does give me 6. And when I look at the right side of my equation, 5 plus 1 gives me 6. And then between them, I can now bring my equal sign down. On purpose, I'm showing that I really want that in the same location, and I'm going to have 6 is equal to 6. And if I were to read the words that would describe the addition property of equality, basically what it's saying is you can add something to the left. And as long as you add it to the right, due to the properties of equality, the result would also be equal. Now, notice that I'm going to move past subtraction for a moment and jump into what these problems look like. We are going to solve equations by adding. And the interesting thing is that to solve these equations where we check our solutions, we are going to be given a subtraction problem. So let's ask ourselves the question, what is the opposite of subtraction? Well, addition. And then what would the opposite of addition be? Subtraction. And what we're really doing is we're performing the inverse operation here. We are doing the opposite to something to undo it. Eyes on the problem. Look at the equation. I'm turning my sketch so I can make a line down the middle. You're not doing that though. And I'm doing that because it's going to help me see that on the left side, I have a value of m minus 48. On the right side, I have 29. The challenge by the end of this problem is to have only m located on the left side, and I'm able to say, well, m is going to be whatever it is. Because m is not by itself on the left, I need to get rid of whatever matches with it. I see minus 48. If I wanted to undo minus 48, I would have to apply the opposite operation. Had I been given a positive 48, I would have had to have subtracted 48. And by the way, really avoid doing 48 plus. That's not where the plus sign is. The plus sign has to be in the front. Same deal with the subtraction. Don't ever write 48 minus, because if I say 48 minus, it's telling me I'm going to subtract something from 48. No, the action is that you're either adding or subtracting here. So below minus 48, I'm going to write plus 48. And on the 29 side, I'm going to write plus 48. What I'm doing here is I'm adding 48 to the left and I'm adding 48 to the right, so that if this is a scale, I'm making the same additions so that they stay balanced and in harmony. Also, I know that at the end I want to keep all this stuff lined up, so I'm being very particular about writing plus 48 below there and plus 48 below the 29. I'm going to bring my equal sign down. On the left side, the 48s go away, but I don't really like to mark things up unless it's really important that I do. So I'm going to bring the m down because negative 48 and 48 went away, and the only thing I had left over here was m. So the m couldn't just disappear. It had to stay in this line of math. And now I'm doing 29 plus 48, but if I'm doing this in my head and it takes me a long time, I shouldn't. The better call would be to pull out a calculator and be like, 29 plus 48 gives me 77. We're pretty sure this is the final answer, so I'll box it. My solution is what I box, to draw attention to it. Now I'm going to rewrite this equation over here, but where I see the variable m, I'm going to plug in the value of 77 because I now know that m is 77. So I read m minus 48, so m is 77. After the m we had minus 48 is 29. And if I type 77 minus 48 into the calculator, I would get 29 is 29. I want your problem to be checked. I avoid boxing 29 equals 29 because that's not what my solution is. My solution is m equals 77. Here I place a check mark because that's saying I checked my problem. Now, if yours looks even slightly different from mine, I really want you to make those minor changes. This plus sign needs to be on the left. It should not be here. These numbers should be lined up. The equal sign should be perfectly aligned vertically. This should be boxed. Over on my other side, the variables have disappeared because I plugged in, but this 77 minus 48, I don't want to see 29 equals 29 written off to the side. I want this to look like we're imagining an invisible line going through our equal signs, and just like an order of operations problem, it's getting smaller and smaller, coming down closer to this balance on that side. Now 29 I just bring straight down, and I want to make sure you have the check as well. 21 plus q equals negative 18. Q is not by itself, but that's going to be our final goal. 21 is with q. In the last problem, 48 was with m. Now, here's the deal. This might look like the same type of problem, but 21 is a positive value. And so the only way I can get rid of that is through subtraction. Because of that, let's fill in this bottom portion here. Let's say I started with the number 8. Now, if I had 8 is equal to 8, I could take away sides from either side. Take away values from either side. So here, maybe I'll subtract 2. While on the right side, as long as I subtract 2, it should still be the same. Well, 8 minus 2 is 6, and 8 minus 2 is 6 again, and since 6 equals 6, I've not messed up this true statement, because that's what equality is. Now, taking a vertical look on the right side, if I had 8 to begin with, equal to 8, I would subtract 2, not just from the left, but also from the right. And the same as I did with the subtraction problem, the addition problem above, I'll draw a line here, and I'm going to say, well, 6 is 6. This is unchanged. So yeah, in these equations, we do have a different result. 6 is 6. 6 is 6. But the whole deal is that our results were always true statements. So yeah, they have different appearances, but they are the same left value and the same right value. Back to problem 2. 21 plus q. Q is not by itself. So the only way that I would ever get rid of 21 with a result of 0 is if I took away 21. And the subtraction property of equality tells me that I'm going to undo this value of 21 by taking it away, not just on the left side, but on the right side, because I have to maintain that balance. 21 minus 21, that went away. I don't like to do that, though. I just like to know that on this left side, q is still left over. I bring my equal sign down. Look how neat this is. My equal sign is directly below it. And then I have negative 18 minus 21. And if I'm not confident with integers, I type that in and I write negative 39, if that's what my calculator tells me. Over here we do our check. 21 is the first thing I see, plus q. Well, the value of q, it's negative 39, so maybe I put this part in parentheses to help me clearly see it. And then after the q I have equals negative 18. And if I type 21 plus a negative, that's okay. But what I'd really like to see is that when you see plus a negative, I'd like you just to turn that into subtraction. And then here I'd get negative 18 is negative 18. And check it. Attempt problem 3 as an OYO problem, recognizing that it is a subtraction problem to begin with, which means that you would actually solve it through addition. So give yourself a moment to figure it out. I'm going to talk more quickly about these now. R was not by itself, it had minus 8. So I'm going to add 8 to get rid of it. 32 and 8 give me 40. I bring my equal sign down, and all I have is R on the right side. Now, I would never say 40 is equal to R. I think R is more important, so I would rewrite this and say R is equal to 40. If you're writing equal signs here, that's just not true. Avoid it. Over on the other side, in that very same line of math, 32 is going to be equal to R, which is 40 minus 8. And then 32 is 32. And put a check mark by it. 7 is equal to 42 plus t. This one's been shuffled around a little bit, probably with the intent of throwing us off. So earlier we had the 21 deal, and there was no symbol in front of it. But we knew it was positive. Now we have 42, and there's no symbol in front of it other than the equal sign, but we know that it's positive as well. And we can't have 42 there. Now let's say you go about this the incorrect way. Watch me subtract 7 from both sides. I'm using red to not write it. Well, 7 minus 7 is 0, equals, 42 minus 7 is 35, plus t. Well, I could keep going and solve this, and I would get the answer. T is negative 35. Let me write that over to the side. Let's see if that ends up being true, doing it the more efficient way. The more efficient way would be to see, well, t is not by itself. It has 42 with it, and I don't like that, so I got to get rid of 42, not just from the right, but also from the left side. And then when I type 7 minus 42 in my calculator, I get negative 35 is equal to t. Now here's the deal. Your equal sign should still be in line, but you have a pencil and you can write more finely than I can. So make sure you're keeping it as neat as possible to where they really do line up. Now lastly, I would not say negative 35 is t. I would say t is negative 35. And reading it left to right feels so much better. Did that check out with doing it the less efficient way? Did we get the same answer? Absolutely. And that's because when you solve equations, you can go about these in most any order you want. And as long as you keep things shuffled neatly, you'll be good to go. So here's 42 plus a negative 35. And then I get 7 is equal to 42 minus 35. I know I'm making you show this extra step. It's probably silly, but I do get 7 equals 7. Let's see. I think it's an appropriate time to stop this video, and we'll maybe do another one for the additional examples.